Hello, everyone, and welcome back. In today's episode, we are going to be talking about how to multiply together expressions containing variables. To begin with, let's talk about how to multiply together two terms. For example, someone says to me, multiply the term 2 times x squared by the term 4 times x cubed. Now, when I'm approaching a problem like this one, it can be helpful for me to remind myself of the meaning of x to the power 2. If I wrote out this product in its full format, 2x squared would be the same thing as 2 times x. And I would like to multiply that by 4 times x times x times x, three copies of x multiplied together. Now, if I multiply the two coefficients, 2 times 4 results in 8. And then, to figure out what would happen with the x's, all I have to do is count the number of x's that I have in this expression. I have a total of 1, 2, 3, 4, 5 x's multiplied together in this expression. So in total, I have x to the power 5 to represent 5 copies of x multiplied together. So here I've multiplied the two coefficients, 2 times 4, and in total, these two multiplied x's combined with these three multiplied x's combined to a total of 5 multiplied x's. Let's also try negative 2x to the fifth power and times negative 8x to the second power. If I wrote this out in full, this would be negative 2 times 5 copies of x multiplied together. And that's going to be multiplied by negative 8 times 2 copies of x multiplied together. Now, if I multiply negative 2 and negative 8, that's an even number of negatives, so the result will be positive 2 times 8, resulting in 16. And here I have 1, 2, 3, 4, 5, 6, 7, a total of 7 copies of x all multiplied together. And 7 copies of x multiplied together is represented by x to the power 7. So here's the product of the two coefficients, negative 2 times negative 8, resulting in 16 as the coefficient of the final answer, and 5 multiplied x's multiplied by another 2 x's gave me a total of 7 multiplied x's, which is x to the 7th power for short. Finally, someone says multiply together 4 times x times y times 3x squared y cubed. Let's go ahead and write this out in full. I have 4 times x times y multiplied by 3, 2 x's, and 3 y's, all multiplied together. So if I multiply the coefficients, 4 and 3, 4 times 3 makes 12. Now let's think about all the multiplied x's I have in this expression. 1, 2, 3. 3 multiplied x's corresponds to x to the third power. And here I have 1, 2, 3, 4 y's. 4 multiplied y's is written as 4 y to the fourth power for short. Let's do another example. Someone asked me to take L times W and raise it to the power 3. What they would like me to do is take L times W and take 3 copies of that and multiply those 3 copies of L times W together. So if I look at this expression, I have 1, 2, 3 copies of L multiplied together and 1, 2, 3 copies of W multiplied together. So this would be equivalent to 3 L's multiplied by 3 W's. And for another example, if someone says, take x squared and then raise that to the power 3, then what I'm doing is I'm multiplying 3 copies of x squared together. Now each of these x squareds is 2 copies of x multiplied together. So if I write that out in full, I can see that what I have here is a total of 6 x's multiplied together. So 6 x's multiplied together can be expressed as x to the sixth power. X to the sixth power is equivalent to x squared, then result raised to the power 3. So this is how we multiply together or raise to a power a term. You can do it just by expanding that term out. If there are any exponents in that term, expanding it out. For example, here, x squared is equivalent to x times x. Y cubed is equivalent to 3y's multiplied together. And then you just have to take stock of what it happens when you multiply those two products together. The two coefficients, the two numbers in front, get multiplied, and then total up any x's that you have, total up all the y's that you have, and rewrite those in an exponent format. Now, there is a little bit of a shortcut that can be nice to do this process more quickly sometimes. And the shortcuts, I should say, can be expressed in three exponent properties. And the first exponent property is this. If I have some base, I will just call it b for short. And that base is raised to some power. I will just call it n. If I multiply it by another copy of the base raised to a different power, then the result of this product is just adding the two exponents together. To give you an example, let's look back at the calculations that we did in these previous exercises. In this work, for example, we had x to the power 2 multiplied by x to the power 3. And if I multiply x to the power 2 and x to the power 3, in total I had 5 copies of x multiplied together. Well, 5 is just the same thing as 2 plus 3. So x to the second power times x to the third power is the same thing as x to the power 5, 5 being 2 plus 3. That idea showed up in this example as well. Here I had x to the fifth power multiplied by x to the second power. So I had a pile of 5 multiplied x's combined with another pile of 2 multiplied x's, giving me a total of 7 multiplied x's in that pile. X to the power 7, x to the power 5 plus 2. The second exponent property that can be used as a shortcut sometimes is what if you are raising a product to a power? What if you have like a times b being raised to the power n? Then in this situation, you can just raise that first factor to the power n times that second factor to the power n. This is very similar to what happened in this example with L times W raised to the power 3. This was just 3 copies of L times W multiplied together, which was equivalent to if we had 3 L's and 3 W's, L to the power 3, W to the power 3. So you can basically just apply a copy of that exponent to each piece of this product. And the final exponent property that can be used as a shortcut sometimes, if you have a base raised to a power, and then you take that result and you raise it to another power. In this case, you can just multiply the two powers together, n times m. And to show you an example of this exponent property, we use that in this last example here, x to the power 2, quantity raised to the power 3. This was 3 copies of x squared multiplied together, which gave us a total of 6 x's, x to the power 6, x to the power 2 times 3. These exponent properties are really handy, especially if you're dealing with exponents that are relatively large, which would make it difficult or time-consuming to write down all the copies of x or y by hand. For example, if somebody said 4 times x to the power 21 times 5x to the power 7, I would very much not want to write down 21 copies of x by hand or 7 copies of x by hand. Instead, I will use the fact that if I have a pile of 21 multiplied x's and another pile of 7 multiplied x's, and I put those two piles of multiplied x's together, and then in total, the number of multiplied x's that I will have is 21 plus 7. In total, I will have 28 multiplied x's. 28 multiplied x's, and then the coefficient 4 times 5 would be 20. For example, here, I do not want to have to write out 2 times x times y 10 times and multiply them all together. That's a lot of writing. Instead, I will just use the property that if you have a product 2 times x times y, and you're raising that product to a power, then you can just apply that power to each piece of the product separately. 2 to the power 10, x to the power 10, and y to the power 10. This pile will contain 10 multiplied 2's, 10 multiplied x's, and 10 multiplied y's. Then all I have to do is use a calculator, for example, 2 to the power 10, to get the coefficient in front. It'll be 1024, so 1024 x to the 10, y to the 10 would be the result of taking 2xy and multiplying together 10 copies of that. And finally, for example, if I wanted to multiply x to the fifth power to the power 30, then I do not want to have to write down 30 copies of x to the 5. Instead, I will say that if I have a base raised to a power, and then I take that result and raise it to another power, then that's equivalent to if I just multiply the two powers together. And in this case, I have x to the power 150 as the result.